So here I will write all the sources, and here I will write about the wavefront. So first source is a point source. Just now we have discussed, for a point source, what is the shape of the wavefront? Spherical wavefront. So this is the source, spherical wavefront. This is how we show the wavefront. As wavefront move ahead, say it is moving in this direction, the direction of ray is always perpendicular to wavefront. So till 10th we study about ray. Now what was the reason for the ray to be formed? It was the movement of the wavefront. So the direction of ray, it's very simple to find the direction of the ray. Whenever there is a given wavefront, the direction of ray is found by drawing a common perpendicular. So if I draw a perpendicular to all these wavefronts, say 90 degree, 90 degree, 90 degree, this is the direction of ray. Now similarly you can draw direction of ray here, direction of ray here, direction of ray here. So for a given point source, the ray will travel in all the directions. Wavefront will be spherical, direction of rays will be in all the direction, right? Now secondly we have taken a linear source. Linear source. Linear source could be a narrow slit out of which a ray of light coming. This is how a narrow slit look like. Suppose we have taken a narrow slit here. This is a narrow slit, right? Out of this narrow slit, some light is coming out. Say we have taken a cardboard, and out of cardboard, light is coming out. How the rays will travel and what kind of wavefront will be formed? So we will take this with the help of a very simple example. Let us take a thread and try to make garland out of thread, right? So how do we make garland? The thin thread of the garland acts as a slit. We assume that it is a slit. So when you keep the first flower, that first flower will act as new source of disturbance. So if this is the slit, this point act as a new source, and this is a point source. We can assume this as a point source. Now what is the shape of the wavefront for a point source? This is spherical. This is also a point source. Next flower, this is also a point source. Similarly, we draw all the point sources, right? Now suppose there is a thread and you are putting every flower in it. Each flower act as a source of, each flower act as a point source. And what is the wavefront for a point source? It is a spherical wavefront. So every flower act as a point source. Suppose the garland is ready now. So many flowers. Every flower is acting as a point source. Now suppose you want to cover that garland with some paper or aluminum foil. Now let us find out what will be the shape of the aluminum foil or envelope, or in this case, assuming the corresponding thing, right? So let us draw a common tangent. Every point act as a fresh source. Let us draw a common tangent to all of them. So I am drawing this common tangent. These were the point sources. The size should be same here, right? So this is the common tangent. Similarly, this is the common tangent on both the sides. Now this shape, what is this shape? This is the shape of a cylinder. Let us assume the garland now. Suppose there is a garland and you want to wrap it with the paper. What will be the shape of that paper? That will be a cylinder. So for a linear source, what is the shape of the wavefront? The wavefront will be cylindrical in shape. So for a linear source, this is the shape of the wavefront. This is how the rays will move. This is the direction of the, this is the axis, this is the slit, this is the source, this was the source here. And now if you draw the next one, how it will be? This is the new source, this is a new source, this is a new source. Similarly, all these source as per the Huygens principle. Similarly, we can draw all the sources here. Every point will act as a new source of fresh disturbance. And if we draw the common envelope to all of them, then we will get the new wavefront. Next wavefront, you can say this is the common tangent, this is the common tangent, again this is the shape of the cylinder. So that is how the wavefront moves in a source where there is a linear source of light, right? Now third is a point source or a linear source. Now we have already studied about both of them, but what is the difference now? Point source or linear source? This is point source, this is linear, but at a large distance. At a large distance. Now the same point source or the same linear source, suppose we are taking it from a distance. So let us say a point source. We are assuming that it is far off. So this is a point source, this is the shape of the wavefronts. I am not drawing the full wavefront. So this is how the wavefront will move at a large distance. Let us take this part. This part is almost straight. This part is almost straight. So what we assume, whenever there is a point source or a linear source but from a distance, we assume that what kind of wavefront is coming? Plane wavefront is coming. And how do we draw plane wavefront? We show plane wavefront by drawing simple lines. Right? How to find the ray? In which direction the ray is moving? Ray is always perpendicular to the wavefront. This is the direction of the ray passing through a plane wavefront. We denote it by plane wavefront, PWF. And this is the direction of the rays, because at every point they will be at perpendicular to the wavefront. I hope you understand, children. So what we have to remember, if the source is a point source, then the wavefront is spherical in shape. If the source is a linear source, the wavefront is cylindrical in shape. And if the point source or linear source are at a distance, then the wavefront, the shape of the wavefront will be plane wavefront. Second thing, the direction of ray will always be perpendicular to the wavefront at every point. Right? Now we are going to discuss behavior of lenses, prism, mirrors when any kind of plane wavefront passes through them. You can also draw it in this shape. This is how a plane wavefront can be drawn. This also represents a plane wavefront. Right? So, spherical wavefront could also have two values. Right? Spherical wavefront could be converging or diverging. Say there are rays which are getting converged at this point. Somewhere the source is here. These are the rays. So what is the shape of the source? Is here, but they are converging to a point. So that is how we draw the spherical wavefront. Spherical wavefront. What nature? Converging nature. At every point 90, 90, 90. That condition is fulfilled in all the cases. Similarly, we can have diverging spherical wavefront. Right? This is a source out of which the light is moving. And what will be the shape? This is how the shape will be. This is spherical wavefront. Which one? Diverging one. So this is spherical wavefront diverging. This is spherical wavefront converging. Right? Now we are going to discuss how prism, how lenses, how mirrors behave when these wavefront follow them. I hope you all remember the ray diagrams, but now it is very simple to draw wavefronts if you remember the ray diagrams. If you don't remember the ray diagrams and you remember the wavefronts, then you can do opposite also. If you remember what kind of wavefront will be formed, you can draw ray diagram. So either of one you have to remember. So let us continue. First we have taken a convex lens. We all know convex lens is thick at the center and thinner at the margins. So we have taken few rays coming from infinity. From infinity the rays are parallel and the image is formed at focus. So now we will not discuss the rays, but we will discuss the wavefront. So for parallel rays, just now we have studied if the rays are parallel, what kind of wavefront? Plane wavefront is considered. So we have taken plane wavefront coming and falling on the lens. Let us say this is the plane wavefront. This is the lens. Let us assume plane wavefront is having three parts for our understanding. This point as A, this point as B, and this point as C. Right? Because if we compare A, B and C, light coming from plane wavefront through A, through B and through C. Now looking at the thickness of the lens, B has to travel more distance. C has to travel less distance. A also have to travel less distance. So which will come out first after refraction? Obviously A will move till here. A will quickly come out and move out till here. C will also move out till here. By the time B, light coming from B will reach here. I repeat, since the light coming from B has to travel more thickness of the lens as compared to the marginal points A and C, right? So they will obviously after refraction they will move out. It will also move out, but the light coming from B will come, say after 1 second, this will reach here, this will reach here, but B will reach here. So this would be the wavefront. After next second, by the time इनके level पे B आएगा, by the time B will come here, this will reach here, this will reach here, and that is how the wavefront is. Sorry, that is how the wavefront is. Next wavefront, next wavefront, next wavefront, and so on. So that is what the diagram tells us in 10th also. Parallel set of rays आ रही है, कहाँ पे converge होंगी? They will converge on focus. They will converge on focus. What kind of wavefront is formed? Here incident wavefront was plane wavefront. Here it is converging spherical wavefront. So whenever a plane wavefront enters a lens, it forms a converging spherical wavefront after refraction. I hope it is clear. Proceeding in the same manner for the concave lens. So there is a set of rays falling on the lens. Parallel set of rays. Parallel set of rays means plane wavefront. Let us say this part, right? Let us name this as A, this as B, this as C. This is the plane wavefront. As compared to A and C, B has to travel less thickness. This much thickness only. A has to travel more, C also have to travel more. Now, B will quickly move, refract and come out. By the time A will reach here and C will reach here. I repeat, A has to travel, the light coming from A has to travel more thickness, C has to travel more thickness. So, say after 1 second they will reach here, this will all reach here, but B would have crossed the small thickness of the lens and reached here. After next second, this will reach, by the time this reaches here and this reaches here, this will travel an extra distance. So, drawing the wavefront, this would be the shape of the wavefront. This would be the shape of the wavefront. What kind of shape? Diverging spherical wavefront. So, that is how the rays would move. Right? At every point, perpendicular, perpendicular. That situation is followed every time. Here also perpendicular, perpendicular at every point. So, this is diverging spherical wavefront. So, when a plane wavefront enters a convex lens, it becomes a converging spherical wavefront. When a plane wavefront enters a concave lens, it becomes a diverging spherical wavefront. Right? Similarly, you can draw for convex mirror and concave mirror also. We'll discuss concave mirror here and we'll also discuss prism here. We have taken a prism and a ray of light is, say a ray of light is entering like this. In 10th standard we have studied a ray of light enters, moves and comes out here, right? So a plane, say these are parallel set of rays. Parallel set of rays means plane wavefront, plane wavefront, plane wavefront. Now you tell me, say A and B. So A, by the time B starts traveling here, A will quickly move, hit maybe a small portion of the prism and start coming out from here. By the time B, say after 1 second B reaches P, Q, R. By the time B enters at Q and leaves at R, by that time A would have traveled up to A dash, right? So this is B dash. By the time B reaches here, A would have traveled extra. So that is how, what is the shape of the wavefront? This is also a plane wavefront. What is the difference between the incident plane wavefront and refracted plane wavefront? The difference is the incident plane wavefront was entering like this. These are the rays. And the refracted plane wavefront is bent towards the base of the prism, which gives the direction of the ray diagram that you draw in